Okay, so let's look at these 3 quick ones. Okay, so let's look at the first one. Oh, you're like, oh, rational function. Yay, you already factored it for me, Miss Brady. Okay, we're going at 2 from the plus. I can't reduce it at all. So let's just check. If you put 2 in, the numerator would be 2 minus 10. Remember, we don't care about the little pluses or minus unless we are close to 0. And then we have a 9. And then here comes the tricky part. You're a little bigger than 2, so like 2.01. So when you put it in this number, you're close to 0, but you're positive. So we get minus 8 over 9 times 0 plus. So this is a negative number that's exploding. So this is negative infinity. Okay, and remember, this means that there's a vertical asymptote on the graph of that function, and it happens where x is worth 2. Okay, let's look at the next one. Super quick, you ready? Okay, why'd they pick 1? Because it makes the denominator 0, and I think it also makes the numerator 0. So if you put in 1, this is 1 minus 4 plus 3, you're like, bam. All right, so I got to do something. Okay, this first one is like a basic form. We could just think about it. This one, we got to do something. Okay, so let's see. So you keep the limit notation until you can evaluate the function or you get it back to a basic form. So I know that I can factor the numerator. That's x minus 3, x minus 1. And then to deal with the absolute values, if you are coming at 1 from the left, pick a number like 999. Okay, so if you put that number in there, this is a negative number. So to take out the absolute value bars, you need to take the opposite of it. So let's do minus 1 times x minus 1. And now we want to see if we can factor. So that factors, or sorry, reduces out. Okay, so now I think we can put 1 in. We would have 1 minus 3 over negative 1, which is minus 2 over minus 1, which is 2. Notice I dropped the limit when I could literally evaluate the function. Okay, last one. Are you ready? Hold on to your hats because here's the hard one. You ready? And imagine just you put in 0, you'd have the square root of 1 minus the square root of 1 over 0. You're like, bam, 0 over 0. So this idea is you need to keep what you started with, and we're going to use that conjugate idea. Okay, so we'll change my color. You can use different colors too. That's super helpful. If you're typing on your documents, switch the color. Okay, so what are we going to times by? X squared plus 1. Change the sign between the terms. X plus 1. You don't want to change the value. So here you go. Okay, I'll go back and grab my other color pen. Okay, so, and again, we're not evaluating yet, so you keep the limit symbol. And why do we pick this? Because we can use the difference as squares. So it's the square of this. So it's x squared plus 1 minus x plus 1. So that multiplying these two, then you have an x. We'll keep this in parentheses because we're going to hope that we can get that x to reduce out. Okay, so let's see what we got. We got the limit as x goes to 0 of x squared plus 1 minus x minus 1, x times all this hot mess. Okay, let's see what happens. I'm going to grab a different color again. Okay, these cancel. And since I want to actually reduce out that denominator so I don't have a 0 in the denominator, we're going to be even more clever. We are going to factor out an x from the numerator. So you have x minus 1 over x, and then all this. Okay, I think we solved our problem because this reduces out. So now we're going to put in x is 0. So I have 0 minus 1 over the square root of 0 plus 1 plus the square root of 0 plus 1. I think that's negative 1 over 1 plus 1, which is negative 1/2. Yay!